Hello, welcome back. So today in this video, we will understand very important concept so that most of the data engineers, especially and the big data developers might have heard. This is a concept of predominantly a big data, and we are discussing today regarding the different file formats of big data, that is Parquet, Avro, and Apache ORC. So basically, these are the three most important file formats that's been mostly discussed when you're talking about big data file formats. So you might have been asking, like, why are you not using CSV, JSON, and all those formats? Yes, so those can also be used in big data, but so those are not so optimized or not recommended for the scenario where the big data comes into picture. So today in this video, we can explore what you can expect is you can expect in detail explanation about what are the what is exactly the file formats, right? Big data file formats, and why do we need this? And what are the different types? When we say different types, that is Avro, Parquet, and ORC, and which is the most optimized format to use in what scenario? We will take certain examples and we'll go in little depth of these explanations, and we will make you understand um, in detail, and you can choose by end of this video. You will be able to choose for your given scenario what file format you can use if you are so that level of knowledge you can expect from this video at the end. So please don't skip any part of the video, so watch till the end. And so if you are new to this channel, please subscribe and also press the bell button for instant notifications. So let's get started. So first let us understand why at all we need these different file formats when it comes to big data, right? So you might be having a question. So we have different file formats like CSV, JSON, and different Excel formats, right? And text format. So why exactly these big data file formats came in, right? So we will try to answer that question here. And if you see, we need to know why. So these are the main aspects or the main parameters why this big data file format should be used. Basically, this will save the space and time. Space, when I'm talking, it's more about the capacity, right, of the disk or the memory, and the time. So time, when I'm talking, it's about the most of the like a query performance. So that is about time, and definitely when you have both space and time is saved, you will have a good performance, right? And the next one is it is a more cost effective, obviously, because it is saving you the space, and it's also helping you optimize your query performance. So definitely it will be a cost effective. And this is actually, these file formats will tackle big data problems. So you might ask me, what is big data problems, right? So there are different big data problems if you are not aware. So like basically there is a volume, there is a velocity, there is a variety of data. With these we call it as a three V's of big data, right? So basically when we call about volume, so the volume is continuously growing, the big data, and that is where the challenge is, because you don't know about the volume, how exactly it grows, and also it is the potential to grow is high. So that is the challenge. How do you plan your the volume and volumetric details for the data? And definitely the velocity at it grows, the pace at which it grows is also challenging to capture and maintain. And the finally the variety is more of data can be like structured, unstructured, semi-structured, or whatever format it can come in. So we have to deal with all kind of data. So that is where to deal with or to handle such kind of data, so you need different file formats apart from the traditional file format. So we are using this. And definitely there are, on top of this, there are different optimization techniques you can apply when you use these kind of file formats. And definitely these are not for like unstructured data. If there is any unstructured data, so then you cannot use that using a non-traditional database systems or something. So you need some different file format. So that is where these different file formats. All right, so next we will discuss what are the different big data file formats. So if you are familiar with the big data technologies or Hadoop technologies, you might have heard about these file formats. So these are the most commonly heard file formats or used file formats. The first one is Parquet, second is Avro, and the third one is ORC. So these are the predominantly these three are mostly used in when you talk about handling uh, big data and its the data which is coming in a the big data format with more volume, velocity, and variety kind of a data. And so, if you really see what exactly we are trying to deal here is, here we are trying to deal with store huge volume of data, and this will actually help in compressing the data and decoupled data and strict schema. So when we say this, store huge volume of data, because these file formats, if you talk about XLS, it is having limitation. If you talk about CSV, it is having limitation. If you talk about text, it is having limitation when you are reading and all, right? So these file formats will actually help in with a different volume, with a huge volume of data, and we can store a lot of data here. And they always store the data in a compressed format. So and it is not that it is stored in the compressed format and you cannot read it. You can read it in a by decompressing it. It is just about compressing and compressing when it is storing, and decompressing when you are reading it. So that is exactly what happens using these file formats. And what is decoupled? Decoupled is nothing but file stored as split formats. So basically one file, if you take one chunk of data, it is not stored in one place or one disk, it is stored across multiple disks or multiple sectors. If you know about operating system in the disk actually, right? When it is actually physically getting stored, it will be stored in a the file will be split and it will be stored in a different locations. So and different nodes basically, right? So when it is stored in different nodes, it can be it will be helpful in doing a parallel processing, because it will be stored in different nodes, and each nodes will be parallelly getting processed. The data will be getting processed, right? And so even though they are decoupled, so once the processing will happen, they will get combined. So that is the beauty of using these file formats. And a strict schema, because of this strict schema only, even though they are decoupled, so they will get processed in different nodes. So this is node 1 and this is node 2, right? And if the data some part of the data is in node process getting in processed in node 1, and other some part is processed in getting node 2, after it is processed, it will be combined and it will form the final copy of the data. So how it identifies that is using a strict schema. So even though it is decoupled and processed parallelly, it will finally get into a one final copy using the strict schema. So hope this was just brief of the three big data formats and what exactly at a high level these does actually. And let us go one by one and understand what exactly they mean and how they are different when compared. All right, you might be wondering why I'm discussing about columnar versus row format instead of going to the different files of different file formats like Parquet, Avro, and ORC, right? So before actually going and jumping into those different types of file formats and understanding them in detail, it is very important to understand what is row format and what is columnar format. So this is very, very important. If you understand this concept, it is very easy to understand the different types of file formats and why they are used. So with that understanding, let us first understand this concept, row versus columnar format, and then we'll jump to the different types of file formats, right? So basically the row format, right? So when you talk about row format, so here we are talking about the data organized by rows, more of a traditional like a database. So if you see about a traditional database, how exactly you are storing the data is here when you talk about the storing or organizing data, it is not at the UI user interface level, right? Because what user sees will be in the tabular format, like rows and columns, but what we are here talking about is how exactly it is stored in the disk, right? It is not always the same, right? How it is stored in the disk. So basically here when you talk about a row format, it will be exactly like tabular format, like row and columns, how you see the database, right? There will be row 1, row 2, row 3, row 4. Similarly, the data will be stored, and all data are associated with a particular row in a are stored adjacently. That means after row 1, okay, there will be row 2 and row 3, row 4, row 5. Similarly like that. So we will see an example how exactly we will see that, right? So basically, if you see, there will be a you want to store this data, right? Which is in a tabular format. So if you see, there is a book ID, name, author, and department. And if you talk about row format, how exactly it actually stores, right? It stores in this format. If you see the first row, right? The first row is always the exact copy of the same row, and second row is exact copy of the second row. Third row is exact copy of the third row. It is exactly storing in a row format, right? That is why it is a row format, right? And what about columnar format? Columnar format are the values of each fields are stored next to each other, right? Read in order is maintained so you can easily tie back the rows. How exactly? What am I talking about here, right? So if you see here, the difference you can clearly note down. So how exactly this is getting stored in the row format and the same data is getting stored in the columnar format. So in the columnar format, what happens is first there will be a first column and all the column values will be stored in that kind of a set. And second, there will be a name and all the column values of the name is stored. Similarly, author and department. So the columns here, the rows, row 1, row 2, row 3. Here it is column 1, column 2, column 3, column 4. So here we are storing in a columnar format, one by one. So that is why it is a columnar format, right? But exactly how it actually stores is we will see in the much more detail. But exactly in this slide, what we are discussing is why we are calling it as a row, why we are calling it as a columnar, because of this. If each row is stored in the row, it is row, and if each column is stored as a row, it is a columnar format. So don't get confused. It might be slightly confusing, but just to see with the example so that you understand this. So now that we have actually understood the row and versus the columnar format, exactly this is like how you organize uh, your books in a shelf, right, as a row format and columnar format. So it actually depends how do you store the data will directly impact or how do you organize the data will directly impact on your query performance and the performance of the query and what exactly the output you get. Uh, so basically it is the traverse time, right? So that we will discuss in the upcoming video. So we have a row versus columnar format continued here. What exactly we want to take an example. So just so that you get the conceptual visualization of what we are talking about. In the previous slide we just seen the definition of it, but we will take an example and understand what exactly the importance of it. So say for example you have a table called books table and it is having a book ID, name, author and price. And what exactly you want to get the output or the use case is find the sum of price of all the books in the store. You want to get the sum of price of all the books in the store. So with that, we will see how happens when you choose the row format and what happens when you choose the columnar format, right? So that you will clearly understand what we are talking about here. So first, let us take about the row format. So row format, as you saw, like it will be stored in the row format. First row will come first, and then the second row, and then the third row. Basically, this first row is linked to second row, and second row is linked to third row. It is like if you heard about linked list, right? It will be linked with each other, right? So that it will not break the thread. So this is how it will be stored in the disk, right? And when you want to exactly go and run this query, right? So here what you're talking about is the price, sum of price, right? So that means you are only interested in the price column. You're not interested in other columns, right? So now let us see what happens. So to get the price from all these three values, what exactly your computer or your input output operation has to do is that it has to go to the first row and get the price, second row and get the price, and third row and get the price. Basically, if you closely observe here, it is actually making a three iterations to get all those values, and then only it can perform the aggregation value, sum of all those values. However, if you choose the columnar format, what happens? So columnar format is stored in this way. So the book ID, if you see, it is stored in, it is basically an invert. If you see, it is an inverted of what exactly you see as a tabular format in a row format. It is actually the inversion of that. So first, it has a book ID 1, 2, 3, and then you have a name, and then you have author, and then you have a price. So now, since you are only interested in the price, what exactly the input output operation does is, so you know what you are interested in, right? You are interested in price. So you can directly go to the price, okay, and get all these three values. Here, if you closely observe, we are making only one iteration compared to previous where we are making the three iteration to get the values. So if you just reach to the price, you got all the values that you want and you can just perform the aggregations. So that's the beauty of how exactly you store the data will impact the query performance and what exactly uh, you are querying, right? So basically, you might ask me which is better. So it again depends on the scenario, right? So if you know what you are querying on, so then it is better to use a columnar format because it just goes to that. But if you don't know what you are querying on, so then it might not be columnar might not be a best format. So there are different scenarios you need to consider and choose among these, right? So now let us take one more example so that it will get more, the conceptually will get more clear. So we will consider the same data, but we will consider here the scenario where we want to write a new row, right? So in this scenario, which is the row, is it a row format or columnar format? Which is the better one, right? Let us see about that. So basically, this is the third column. You want to make an entry to this existing data, and first we will take a row format and see what exactly happens. So if you're choosing row format, there is already a linked thread between 1 and 2, and so from 2 you just need to link to the third row. You just need to establish one more link here. So what exactly you are doing here? You need to establish one more link. So this is only one iteration that you are doing here to actually append or insert a new row here to this list. However, let us do a columnar format. So in the columnar format, what exactly happens? So you want to enter the four values. Basically, there are four values here, right? For all the four values, you have to make four iteration because first you will go to the book ID and you make a book ID entry here, and next you go to the name and you make a name entry here, then author entry here, price entry here. Basically, here it is one versus four iterations. Okay, so let us quickly go back to the previous scenario, right? We have explained. In the previous scenario, if you see, if this list grows, right, you can imagine how many number of iteration that you have to do if you choose the row format. If there are like millions of rows, you are making such many disk intensive IO operation. So if you want to just find the sum of price, if you are using a row format, if you are using columnar format, it is just one. Basically, it is n is to, if you compare, it is 1 is to n. So here you are making one iteration, but here you are making n iteration. How many number of rows? Similarly, when you come back to the current example that we have taken where we are writing a new row. So here writing a new row for existing one, here we are taking one iteration in the row format, but here we are taking four iteration. Suppose if there are like take for example there are 200 columns. If there are 200 columns, it used to be here it used to be one iteration and here it used to be 200 because you need to enter the value for each of the columns, right? Here there are four columns, that's why you are making four iteration. If there are 200 columns, to insert just one record you have to make 200 traversals. So now hope you are able to understand the intensity of what we are talking about here. So with that, I hope you have a clear understanding now about row and columnar format. If this concept is not clear, I would recommend you to please go back and see the video in a much more better way and much more take examples and try to understand. Take a different example and try to understand by yourself so that the next slides will be easily understood. So now let us quickly jump to the next slide where we will talk about start talking about the different file formats. So now first let us take about the Avro file format. So Avro file format is a row based. Previously we saw what is row based, and so it is about a row based, and it is open source technology created by Apache in 2009, right? And so it is basically suitable for Apache Kafka. So the reason is it is a streaming Apache Kafka when you talk about is a streaming data which is coming in, and Avro good support in when you're writing too many data, continuous data, or too many writes are happening. Avro is very suitable for that. So it actually bundles the serialized data with the data schema in the same file, so it is easy to deserialize. And the schema stored in a JSON format, and the data is exactly stored in a binary format as a compacted or compressed format, right? So here the just the schema is stored in JSON. Don't get confused, but the data is actually compacted and stored in a binary format. So this actually supports dynamic schema evolution. What that means is, suppose today you are having like 10 columns in a table or a data set. Tomorrow, if you want to have 11 column, 12 column, you can add the column number of columns, or delete the number of columns, or rename the columns. So that is what we call it as a dynamic schema evolution. And it actually supports array, enum, and map and unions, and it's also splittable. So what is splittable? So splittable is again the same concept that we discussed in previous slides. If the file is splittable and it can be placed in the different nodes, so that it can be so that the data can be processed using parallel processing. So definitely Avro is one example of it, right? And when to use, right? When to use Avro is when there is a write intensive operation. Basically, you are having too many writes. Suppose I take example of OLTP system, right? So when we take a OLTP, where what exactly you are doing is you are continuously writing a data because it's a transactional system. So you actually write on every second or every hour. So frequently you are continuously writing the data to the data set. You are appending the data or updating the data. So basically, in that kind of operations, Avro is best suitable, and that's why it is also recommended to use when you are using a Kafka kind of a application as a upstream. And it is very, I mean, you can use schema evolution. It supports schema evolution when it is very critical. You can definitely use Avro file format. So now let us go for the ORC file format. So which is the optimized row columnar format. So previous one is the right. Previous one was actually the if you see Avro file format, right? It was a row based, and now what we are talking about the ORC, it is a row columnar. That means it is the combination of both row and columnar. That is why we are calling it as row columnar. So basically, it is the previously it was if you are familiar with the RC file format, it is the evolution version of RC, which is row columnar, and that's the it is the optimized version of RC file format, right? And ORC file format store basically in a columnar, and it is open source, which came in 2013 for Hadoop, and this is predominantly used for Hive. So keep this in mind. If you are using a Hive kind of tables, it is actually better to use a ORC, right? Because it's compatible for storing that Hive data efficiently. And complex types supported like datetime, decimal, struct, list, map, union, and separate record reader for concurrent reads for a single file that we will see in a just in a while. And it also supports the ACID when you are using ACID transaction when you are using Hive. So let us quickly see the ORC, how the exactly ORC is stores the data. So you take any data, so it is having a tabular format, right? As we have discussed, like a books table. So the table you'll be having multiple records. So each record here is stored in this format where it will be having index, record, and strip footer, index, record, and strip footer. And the entire, if you see, it will be entire ORC file. It will have one header and it will have one footer. So basically, what exactly it means is this enables us to kind of actually store the metadata information. And by default, whatever one strip, we call it as a one strip, this one, right? So this is actually by default, it will be 250 MB, right? So this is 250 MB, and similarly, this will be 250 MB. So with this large strip, what will happen is like ORC file format offers superior compression characters, right? And basically it can have a compression techniques like snappy, zlib, and all. And it also have a predicate push down. That means the system checks a query or condition against file metadata to see whether the row must be read or not. So basically it can skip the row. This increases the potential of skipping the data and making it more faster. So when to exactly use this, right? If there is a read intensive operation you're doing, so if you are reading a lot of data instead of writing it, so it is actually suitable for OLAP because you are doing a lot of reads here, right? And Hive is significantly used. So in that case also you can use this. And when you need more flexibility for compression, you want to choose different compression techniques because ORC supports almost all compression techniques. In that case, you can choose. Now let us move to the one of the most frequently used, I would say, or most famous. And actually, if you have heard about big data and cloud technologies as a data engineer, so definitely you might have used or heard about Parquet file format. So let us see what exactly the Parquet file format. So Parquet file format is basically a columnar based. So if you talk about Avro, it was actually a row based, right? And if you talk about ORC, it is a row columnar based. So now we're talking about Parquet, right? So Parquet is actually a columnar based. So it's purely columnar based, and it is open source released in 2013 for analytical querying. So this is very, very important because this is what it made Parquet to actually more used in the today's world, because today's world runs on the analytics and fast analytics. You want everything to be quick in terms of doing analytics on a big data. So basically, this power of actually analytical querying in a with a good performance make Parquet unique. And efficient data compression and encoding schemes with the enhanced performance. We are using enhanced term because the previous technologies are the traditional way of storing, like ORC and Avro were a traditional way of storing the data, but Parquet is actually enhanced version of them, and it actually much better in terms of the performance generally, right? And it actually supports complex nested types, okay, and also with multiple compression techniques. And like other file formats, it's also splittable, and also it supports the schema evolution. So mostly this will be used in OLAP. So again, this is important, right? So why we are calling it as OLAP? Because it's an analytical platform. Since it is very good in writing an analytical query, so it is mostly used in or mostly suitable for OLAP, and enables data skipping, reduced IO. So data skipping is again a very important concept architecturally. So in the previous slide also you have seen how the data skipping happens. So if you are like actually doing a data skipping, so it actually reduces your IO performance, and that is what it makes Parquet as a highly efficient data compression and decompression file format. So they also feature increased data throughput and performance using techniques such as data skipping, in which the query returns specific column and do not read the entire row of the data, generally minimizing the input output. So Parquet, since it is a like a little important format, so I want to take one example and make you understand how exactly it stores and how exactly it works, right? So let me clear this, right? So how exactly it is storing the data? So if you take an example, actually the row one, if you see like group here, the data is getting stored in a groups, multiple groups. So in the group one, if you closely observe, we have data of column one and column two. And if you see group two, you have data of column three and column four. And the metadata of group one and group two is stored in the footer. So in the footer, if you see, it is storing the metadata that is of group one, metadata of group two. So group 1 is having metadata of column 1 and metadata of column 2. Similarly, group 2 is having metadata of column 4, column and column 3. So basically it can grow like a number of groups based on the how many data you have. So now we are taking only 4 columns. So that is why it is grouped into multiple two groups. So basically in footer also we have group 1 metadata, group 2 metadata, and it can grow till group n metadata. And this group 1, group 2 can grow till group n, right? Basically this is how the physically store the Parquet will store its data. So there will be a pointer like when you want to process any data, it will go to the footer and it will take the where exactly the group one metadata stored, and then it will go to the column one, and with the column one it can actually go to the exact data where it is stored, and with the column two it can go to the exact data of column two where it is stored. Similarly, column three and column four. So this is how the Parquet file format will work. You know, how exactly it stores and it retrieves the data. Now let us take one example for Parquet and understand in much more detail. So I want you to understand Parquet with more details compared to Avro and ORC. The reason is Parquet is mostly used in the current projects or current technologies that you are using, because if you heard about Delta Lake or Delta concept of Databricks, so definitely it is completely built on Parquet, and Parquet is the most used file format. So that why I want you to understand Parquet in much more detail. So let us take example of Parquet here and understand. So if you want to store this data, which is again a books table, and where you have book ID, name, author, price, and category. So you have a use case to find sum of product of all the books from finance department. Basically, you need to understand finance category in the store. Sum of price of all the books from the finance category. So basically, you need to concentrate on category and price here. So these are the two attributes, right? And now let us see how the Parquet will try to retrieve this data. As you know, Parquet will group the data. So few columns will be taken in first group. Like let us take first and two column in first group, and third and fourth column in second group. So after splitting it, as you can see, the data is split into two parts, and group one is having name and author, and group two is having price and category. So basically group one might be in different disk, right? Or it might be physically stored in different node. And similarly, group two also might be stored in different group and different node. So now, so when you try to query this, what happens? So actually, the query will go and see what exactly you need. You need price and category. So it will go and see where I can get price and category. So since it comes to know price and category can be the information can be retrieved only by group 2, because in this to obtain the details that is needed for this use case, you don't need group 1, so you just need group 2. So that is why it won't go to group 1, right? It just does the job with a group 2. So basically physical traversal will not happen. If you see the previous slide that we were discussing, so here only the first iteration will happen here, right? So for this will not happen. You have a group 2, right? So only this will happen. So basically you are not worried about group 1. So you just need the data of group 2 and you just go and get it. And all the information metadata is stored here, and using this only you will do the traversal. So now you know the difference, why exactly how powerful the Parquet can be. And if you're talking about like hundreds of columns in this particular use case, and there will be hundreds of groups, right? So in that case, also you just need to go use one group. So all the other groups will be ignored, like group one. So that is a advantage of using such storage. How exactly you store in the data in the disk will actually determine how powerful uh, you can query and you can get the performance. So finally, we'll go to the summary section and quickly understand how the different file formats actually put together. So if you see here, like we have just put a comparison, high level comparison. So just keep this in mind when you are choosing the file format for your project or for your use case. So you need to choose between Avro, Parquet, and ORC. So then keep a few parameters in the mind. So the first one is schema evolution. So schema evolution, if you want to do, the Avro is the best format and it is more flexible option. In Parquet also you can do it, but when you execute schema evolution, so as you can see here, this having a less portion. The reason is it is not mostly used for schema evolution, because even though you run the schema evolution rules, it runs it, but it takes some good amount of time to apply that schema evolution. Similarly for ORC, but Avro is such a format which quickly does the schema evolution. And similarly the compression all the formats will do, and the most best compression you can find in ORC, because it supports almost all the compression techniques and it actually does the compressions much faster and quicker compared to the other file formats. And if you talk about splittability, again, the ORC is a best format where it actually quickly can split and give much more performance. And finally, if you talk about the compatible platform, as I told, Kafka, right? Kafka is basically used for streaming writes. So continuously you are writing a data. So then since Avro is good for writing, so that is the most optimal solution for it. I mean, choosing the Avro will be the best decision. And if you have a Impala, Arrow, Drill, and Spark, so the important thing here is Spark. So since most of the projects are using Spark, so the best file format, you know what to use, right? And if you are using a traditional Hive, which is a big data, traditionally big data concept, or Presto, which is again a big data concept, traditional big data concept, so then ORC is a better one. And so row or columnar format. So by now you should be definitely knowing which is row format. So Avro is a row format, Parquet is a columnar format, and ORC is also columnar format. And finally the read write. So read write is nothing but which is suitable for read, which is suitable for writes. So definitely Avro is suitable for writes, that is OLTP, that is transactional processing, and Parquet and ORC is suitable for analytical processing, that is OLAP. So in the today's world, if you ask me, so the Parquet is a winner, because definitely you are using a Spark here, which you can do a lot of optimization on Spark. So there is a lot of optimization techniques that you can run on Spark. So even though you are using Parquet, it doesn't mean that it's the end of a story. You need to do a lot of partitioning, bucketing, and there are a lot of Spark optimization techniques. And Parquet is also having good support, community support, and all the different architectures and optimization architectures are being built on Parquet. Like take for example the Delta Lake of Databricks, which is a Delta concept, which again is built on top of the Parquet file format, which actually makes it much more the favorite file format among the engineers and the architects. So this is about it. And if you ask me which is the most file format, you know the answer now. The most highly used file format is Parquet, and I would choose for any analytical platform. So I would use Parquet, and if it is you are using a traditional file format or a Hadoop kind of a use case, then go for ORC or Avro. But always the favorite option is Parquet because of its analytical support and the programming optimization using Spark, and also the community which is supporting by making it more optimized way by using by building architectures around it. So with that, we reach end of this video. So hope this was useful, and now definitely you will be understanding what is a different file format, and you go for any interview or you are just using in your project. So it makes it very important to understand these differences. And if you have any queries around this, please comment in the comment section. I'll try to explain with much more different examples. So thanks for watching.